Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello, everyone, and welcome back to another episode of MLOps Live. I'm Sabine, your host, and I'm joined as always by my co-host, Steven.
Hi, everyone.
And today we have with us Jason Flaks, and we'll be talking about deploying conversational AI products to production. Hi, Jason, and welcome.
Hi, Sabine. How's it going? Hi, Steven.
Going very well and looking forward to the conversation. So, Jason, you are the co-founder and CTO of Xembly. Xembly, am I saying that right?
You are saying that correctly. Very good.
Awesome. So it's an automated chief of staff that automates conversational tasks. So it's a bit like person or executive assistant bot. Is that correct?
Yeah, that's a great way to frame it. So the CEO of most companies have people assisting them, maybe an executive assistant, maybe a chief of staff. And we do that today because we hope that the CEO can focus their time on really important and meaningful tasks that they can do that power the company. And we hope those assistants can help handle some of the other tasks, in their day, like scheduling meetings or taking meeting notes. We are aiming to automate that functionality so that every worker in an organization can have access to that help, just like a CEO or someone else in a company would.
Awesome. We'll be digging into that a bit more in just a moment. So just to ask a little bit about your background here, you have a pretty interesting one. You have a bit of education in music composition and math and science before you got more into the software engineering side of things. But you have started out in software design engineering. Is that correct?
Yeah, that's right. As you mentioned, I did start out earlier in my life as a musician. I had a passion for a lot of the electronic equipment that came for music, and I was good at math as well. And so I started in college as a music composition major and a math major, and then was ultimately looking for some way to combine those two. I landed in a master's program that was an electrical engineering program exclusively focused on professional audio equipment. And that led me to initial career in signal processing doing software design. And that was kind of my out of the gate job.
Awesome. So you find yourself in the intersection of different interesting areas, I guess.
Yeah, that's right. I've really always tried to stay a little bit close to home around music and audio and engineering. Even to this day, while I've drifted a little bit away from professional audio, music, live sound, speech and natural language is still tightly coupled into the audio domain. So that's remained kind of a piece of my skill set throughout my whole career.
Absolutely. And on the topic of equipment, you were involved in developing the Kinect, right? For the Xbox. So was that your first touch with like speech recognition, machine learning application, or?
That's a great question. So a funny thing about speech recognition is it's really a two-stage pipeline. The first component of most speech recognition systems, at least historically, are extracting features that's very much in the audio signal processing domain. Something that I had a lot of expertise in from other parts of my career while I wasn't doing speech recognition. I just was familiar with fast Fourier transforms and a lot of the componentry that goes into that front end, the speech recognition stack. But you're correct to say that when I joined the Kinect camera team, it was kind of the first time that speech recognition was really put in front of my face. I really naturally gravitated towards it because I deeply understood that early part of the stack. And I found it was really easy for me to transition from the world of audio signal processing, where I was trying to make guitar distortion effect, to suddenly breaking down speech components for analysis. It really made sense to me, and that's where I kind of got my start. It was a super compelling project to get my start because the Kinect camera was really the first consumer commercial product that did open microphone, no push to talk speech recognition. at that point in time, there were really no products in market that allowed you to talk to a device without pushing a button. You always had to push something and then speak to it. We all have, Alexas or Google Homes now. Those are really common, but before those products actually existed, there was actually the Xbox Kinect camera. And you can actually go traverse the patent literature and actually see how the the Alexa device references back to those original Kinect patents. It was truly an innovative product.
Yeah, and I remember I once had a lecturer who said that about the human speech, that it's the single most complicated signal in the universe. So I guess there's no shortage of challenges in that area in general.
Yeah, that's really true.
Awesome. So before we go deeper into the questions here, just a bit of housekeeping. This is going to be released as a podcast later on, just as a reminder, so you can catch up with the recorded episode a bit later. And this is an interactive Q&A as well. So if you're present here in this session, you can raise your hand in Zoom and ask your question live. You can also type it in chat here and we'll pick it up at a suitable time. Or if you want to ask anonymously, you can just DM me here in Zoom, or you can write in LinkedIn as well, and we'll pick it up from there. All right, so Jason, to kind of warm you up a bit more here, in 1 minute, how would you explain to us conversational AI?
Wow, the 1 minute challenge. I'm excited. So human dialogue or conversation is basically an unbounded infinite domain. And so conversational AI is really about building technology and products that are capable of interacting with humans in this unbounded conversational domain space. So how do we build things that can understand what you and I are talking about, partake in the conversation, and actually transact on the dialogue as it happens as well?
Awesome. And that was very condensed. It was well within the...
I felt a lot of pressure to go so fast. I overdid
it. No worries. We have plenty of time to go deeper. So I wanted to ask a little bit about what your team is working on now. So are there any particular aspects of conversational AI that you're working on?
Yeah, that's a really good question. So there's really two sides of the conversational AI stack that we work on. So one is at the chatbot side, enabling people to engage with our product via conversational speech. As we kind of mentioned at the start of this conversation, we are aiming to be an automated chief of staff or an executive assistant. And the way you interact with someone in that role is generally conversationally. And so our ability to respond to employees via conversation is super helpful. So that's one part of the stack. The other very large part of our stack is the ability to do automated note-taking. So the question becomes, how do we sit in a conversation like this over Zoom or Google Meet or any other video conference provider and actually generate well-written prose, notes that you would immediately send out to the people in the meeting that explain what happened in the meeting. So this is not just a transcript. This is how do we extract the action items and decisions and roll up the meeting into a readable summary such that if you weren't present, you would know what happened. Those are probably the two big pieces of what we're doing in the conversational AI space. And there's a lot more to what makes that happen, but those are kind of the two big product buckets that we're covering today.
Mm-hmm. So if you could sum it up on a high level, how do you really go about developing this for your product?
Yeah, so let's talk about note-taking. I think that's a really interesting one to walk through. To really develop that product, I think first required us to break down the problem. So meeting notes is actually a really complicated thing on some level. There's a little nuance to how every human being sends different notes. And so it required actually taking a step back and trying to figure out what's the core, what's the nugget of what makes meeting notes valuable to people, and can we quantify it into something that's structured that we could repeatedly generate, right? Machines don't deal well with ambiguity. And so you need to have a structured definition around what you're trying to do, both so that your data annotators can actually label information for you. If you can't give them really good instructions on what they're trying to label, you're going to get wishy-washy results. But also just because in general, if you really want to build a crisp, concrete system that produces repeatable results, you really need to define the system. So we spent a lot of time up front actually just figuring out what is the structure of proper meeting notes. In our early days, we definitely landed on this notion of there are really two critical pieces to all meeting notes. There are the actions that come out of the meeting that people need to follow up on. And then there's basically some type of linear recap that summarizes what happened in the meeting, ideally topic bounded, so that it covers like the sections of the meetings as they happened. So once you kind of have that framing, you have to make that next leap to then define what those individual pieces look like so that you understand what the different models in the pipeline that you need to build to actually achieve it. Does that make sense?
Yeah, I think it makes sense to us as well. Was there anything else you wanted to add to that?
Yeah. So if we think just a little bit about something like action items. So how does one going about defining that space so that it's actually something that's tractable for a machine to find? A really good example is that in almost every meeting, people say things like, I'm going to go out and walk my dog, because they're just conversing with people in the meeting about things they're going to do that's non-work related. So you have things in a meeting that are non-work related. You have things that are actually happening in a meeting that are actually being transacted on at that moment. I'm going to update that row in the spreadsheet. And then you have true action items, things that are actually work that must be initiated after the meeting happens that someone's accountable for that's on that call. So how do you scope that and really refine that into a very particular domain that you can teach a machine to actually find? Turns out to be a super challenging problem. We've spent a lot of effort doing all that scoping and then initiating the data collection process so that we can actually start building these models. On top of that, you have to figure out, well, what is the pipeline to actually build these conversational AI systems? Actually twofold. There's understanding the dialogue itself, just understanding the speech, but to actually transact on that data in a lot of cases requires that you normalize that data into something that a machine understands. A really good example is just dates and times. Part one of the system is understanding that someone said, I'll do that next week, but that's insufficient to transact on its own. If you want to transact on next week, you have to actually understand in computer language what next week actually means. That means you have to some reference to what the current date is. You need to actually be clever enough to know that next week actually means some time range that is in the following week from the current week that you're in. And there's a lot of complexity and a lot of different models that you have to run to be able to do all of that and be successful at it.
Oh yeah, I bet. So we are heading into the more technical and detailed questions here next with Stephen.
All right, awesome. Thanks, Evan. And thanks, Jason, for your answer there. And I'm sort of looking at digging more deeper into the note-taking. That's a product you talked about. And I'm going to be coming from the angle of production, of course, getting that to real-world users, and the ambiguity there stems from there. So before I sort of go into that complexity, I just want to understand, how do you go on and deploy such products itself? Are there specific like nuances or requirements that you put in place, or this is just very typical pipeline deployment and then it's workflow and then that's just it? Or are there things that you found that has been different from other methods of deployment?
Yeah, that's a good question. So I'd say first and foremost, probably one of the biggest differences in conversational AI deployments in this note-taking stack, perhaps from the larger traditional machine learning space that exists in the world, relates to what we were talking about earlier, is because it's an unbounded domain, fast iterative data labeling is absolutely critical to our stack. And really, if you think about how conversation or dialogue or just language in general works, you and I can make up a word right now. And far as even the largest language model in the world, if we want to take GPT-3 today, that's an undefined token for them. We just created a word that's out of vocabulary. They don't know what it is. They have no vector to support that word. And so language is a living thing. It's constantly changing. And so if you want to support conversational AI, you really need to be prepared to deal with the dynamic nature of language constantly. And that might not sound like that's actually a real problem, that people are creating words on the fly all the time. But it really is. Not only is it a problem in just the general two friends chatting in a room, but it's actually even a bigger problem in the business perspective, because every day someone wakes up and creates a new branded product and they invent a new word like Xembly to put on top of their thing. And you now need to make sure that you understand that. So a lot of our stack, first of all, out of the gate, is making sure that we have really good tooling for data labeling. We do a lot of semi-supervised type learning. So we need to be able to collect data quickly. We need to be able to label it quickly. We need to be able to produce metrics on the data that we're getting just off of the live data feeds, so that we can use some unlabeled data with our labeled data mixed in there. I think another huge component, as I kind of was mentioning earlier, conversational AI tends to require large pipelines of machine learning. You usually cannot do like a one-shot, here's a model, it handles everything. No matter what you're reading today in the world of large language models, there's generally a lot of pieces to make an end-to-end stack work. And so we actually need to have a full pipeline of models. We need to be able to quickly add pipelines into that stack. It means you really need good pipeline architecture such that you can interject new models anywhere in that pipeline as needed to make everything work as needed. Did that kind of answer your question?
Oh, yes, that does. And I think we're going to be digging into the data part of things later on in the episode, because I think that's probably one of the things that teams building conversational AI products struggle with a whole lot. But maybe if you could walk us through sort of your end-to-end stack for case in points, the notebook products, and let's just sort of see how much of a challenge each one actually poses and maybe how your team solves them as well.
Yeah, the stack consists of multiple models. It starts at the very beginning with basically converting speech to text. It's like the foundational component. So traditional speech recognition, how do we take, the audio recording that we have here and get a text document out of that? Because we're dealing with dialogue, and in many cases, dialogue and conversation where we don't have distinct audio channels for every speaker, there's another huge component to our stack, which is speaker segmentation. I might wind up in a situation where I have a Zoom recording, for example, where maybe there's 3 independent people on channels, and then there's 6 people in one conference room talking on a single audio channel. So to actually make that transcript that comes out from the speech recognition system actually map to the dialogue flow correctly, we need to actually understand who's distinctly speaking across that transcript. It's not good enough to say, well, that was conference room B, and there was 6 people there, but I only understand it's conference room B. I really need to understand every distinct speaker, because part of our solution requires that we actually understand the dialogue, the back and forth interactions. I need to know that this person said no to this request made by another person over here. So we net out with text. In parallel, we net out with speaker assignment, who we think's speaking. We start a little bit with what we call blind speaker segmentation. So that means we don't necessarily know who is whom, but we do know there are different people. And then we subsequently try to run audio fingerprinting type algorithms on top of it so that we can actually identify specifically who those people are if we've seen them in the past. Even after that, we kind of have one last stage in our pipeline. We call it our format stage. So we run punctuation algorithms and a bunch of other small pieces of software so that we can actually net out with what looks like a well-structured transcript, where we've really kind of landed in this stage now where we know Sabine was talking to Stephen, was talking to Jason. We have the text that allocates to those bounds. It's reasonably well punctuated. And now we have something that is hopefully a readable transcript. From there, we actually fork our pipeline. So we run in 2 parallel paths, one trying to generate action items and the other one trying to generate these recaps. So let me take you down each of those independently. So for action items, we run proprietary models in-house that are basically attempting to find spoken action items in that transcript. But that turns out to be insufficient, because a lot of times in a meeting, what people say is, I can do that, If I gave you meeting notes at the end of the meeting and you got something that said action item, Steven said, I can do that. And that wouldn't be super useful to you, right? So there's a bunch of things that have to happen once I found that phrase to actually make that into well-written prose, like I mentioned earlier. So we have to dereference the pronouns. So we have to go back through the transcript and figure out what that was. We reformat it. So we actually try to restructure that sentence into something that's well-written. So like starting with the verb, replacing all those pronouns. So I can do that turns into Stephen can update the slide deck with the new architecture slide. The other things that we do in that pipeline, we run components to both do what we call owner extraction and due date extraction. So owner extraction winds up being basically understanding that the owner of that statement was I, and then knowing who I pertains to back in that transcript from the dialogue, and then assigning the owner correctly. Due date detection, like we mentioned, is how do I find the dates in that system? How do I normalize them so that I can present back to everyone in the meeting? Not that it was just due on Tuesday, but Tuesday actually means January 3rd, 2023, so that perhaps I can put something on your calendar so that you can get it done. That's the action item part of our stack. And then we have the recap portion of our stack. So along that part of our stack, we're really trying to do two things. One, we're trying to do blind topic segmentation. So how do we draw the lines in this dialogue that roughly correlate to kind of sections of the conversation? When we're done here, someone would probably go back and listen to this meeting or this podcast and be able to kind of group it into sections that seem to align to some sort of topic. We need to do that, but we don't really know what those topics are. So we use some algorithms. There are things that we like to call change point detection algorithms. We're looking for kind of systemic change in the flow of the nature of the language that tells us this was a break. Once we do that, we then basically do abstractive summarization. So we use some of the modern large language models to generate well-written recaps of those segments of the conversation, so that when that part of the stack is done, you net out with two sections, our action items, and now our well-written recaps, all with nicely written statements that you can hopefully immediately send out to people right after the meeting.
Right. It seems like a lot of like models and sequence, and feels like complex, a lot of overhead, I would say, which is really exciting for us as we can slice through most of these things. But I'm looking at you mentioned most of these models being like in-house proprietary, but I'm just kind of curious, where do you sort of leverage those state-of-the-art transformer-based or off-the-shelf models, and where you feel like maybe this has already been solved versus the things that you think are just in-house, that can be solved in-house, but based on this particular use case of yours in-house?
Yeah, so we try not to have the not invented here problem. We're more than happy to use publicly available models if they exist and they help us get where we're going. There's generally one major problem in conversational speech that tends to necessitate you build your own models versus using off the shelf. And that's just because the domain that we talked about earlier being so big that you actually can net out having a reverse problem by using very, very large models. And that statistically, language at scale may not reflect the language of your domain, in which case using like a really large model actually can net out with not getting the results that you're looking for. We see this very often actually in speech recognition. So a really good example would be a proprietary speech recognition system from, let's just say, Google, for example. One of the problems that we'll find is Google has had to train their systems to deal with transcribing all of YouTube. And the language of YouTube does not actually generally map well to the language of corporate meetings. And it doesn't mean that they're not right from the larger general space. They really are. I mean, YouTube's probably a better representation of language in the macro domain space. But we're really dealing in a subdomain of business speech. And that means that if you're probabilistically, like most machine learning models are trying to do, predict words, and you're based off the general set of language versus the kind of constrained domain of what we're dealing with in our world, you're often going to predict the wrong word. And so in those cases, we found it's actually better to build something, if not proprietary, at least trained on your own proprietary data in-house versus using off-the-shelf systems. That said, there's definitely cases at summarization. I mentioned that we do recap summarization. I think we've reached a point where you would be silly to not use a large language model like GPT-3 to do that. It has to be fine-tuned, but I think you'd be silly to not use that as a base system because the results just exceed, I think, what you're going to be able to do. I mean, that's a situation where summarizing text, it's actually really difficult to do that well and make it like really, really readable. And the amount of text data that you would need to acquire as a small company to actually train something that would do that well, it's just not conceivable anymore. So now you have these great companies like OpenAI that have done it for us. They've gone out and spent ridiculous sums of money training really, really large models on amounts of data that would be difficult for any smaller organization to do. And we can just leverage that now and get some of the benefits of these really well-written summaries that all we now have to do is just adapt and fine-tune to tweak it to get the results that we need out of it.
Yeah, that's quite interesting. And maybe I'll log us to deeper into these challenges you face because running a complex system can range from maybe maybe the team setup to, of course, problems with compute. And then you talked about quality data. But in your experience, what are the challenges that really help sort of break the system in quotes? And then you'll go back there and fix them and get them up and running again.
Yes, there's a lot of problems in running these types of systems. So let me try to cover a few. I'd actually say just before even getting into the live inference production side of it, one of the biggest problems is like what we call machine learning technical debt when you're running these daisy chain systems. So we have a cascading set of models that are dependent or can become dependent on each other. And that can become really problematic because if you train your downstream algorithms to handle the error coming from your further upstream algorithms, then suddenly if you introduce a new system, you can have chaos. So, right, if my transcription engine makes a ton of mistakes at transcribing words, a funny example would be, we have a gentleman on my team whose name always gets transcribed incorrectly. It's a difficult name from not a traditional English name. It constantly gets mistranscribed. If we build our downstream language models to try to mask that and compensate for it, what happens when I suddenly change my transcription system or put a new one in place that actually can handle it? Now everything falls to pieces and breaks. So one of the things that we really try to do is not bake the error from our upstream systems into our downstream systems. We always try to assume that our models further down the pipeline are operating your data so that they're not coupled. And that allows us to independently upgrade all of our models in all our system with ideally not paying that penalty. Now, we're not perfect. We strive to do that. Sometimes you run into a corner and you have no choice, but to really get quality results, you have to do that. But ideally, that's one thing that we really strive for, complete independence of the models in our system so that we can update them without then having to go update every other model in the pipeline. Because that's really the danger that you can run into, which is, well, suddenly now I updated my transcription system. I'm getting that word I wasn't transcribing anymore, but now I have to go upgrade my punctuation system because that changed how punctuation works. I have to go upgrade my action item detection system because my summarization algorithm doesn't work anymore. I have to go fix all that stuff. And you can really trap yourself into a dangerous hole where the cost of making changes becomes extreme. So that's one component of it. The other thing I think that we found is when you're running a daisy chain stack of machine learning algorithms, you need to be able to quickly rerun systems through your pipeline and any component of your pipeline. Basically, I think to come down to the root of the question that you were asking me is we all know things break in production systems. It happens all the time. I wish it didn't, but it does. When you're running queued daisy chain machine learning algorithms, if you're not super careful, you can either run into systems where data starts backing up and you have huge latency, if you don't have enough storage capacity in wherever you're keeping that data along the pipeline, things can start to implode. You can lose data. All sorts of bad things can happen. So if you properly maintain data across the various states of your system and you build really good tooling so that you can constantly, quickly rerun, restart your pipelines, then you can find that you can get yourself out of trouble. So we built a lot of systems internally so that if we have a customer complaint or something like that, they didn't receive something they expected to receive, and we can go quickly find where it failed in our pipeline and quickly reinitiate from precisely that step in the pipeline after we fixed any issue that we uncovered. Maybe we had a small bug that we accidentally deployed. Maybe it was just an anomaly. We had some weird memory spike or something that caused the container to crash mid-pipeline. So, we can quickly just hit that step, push it through the rest of the system, and exit it out the end to the customer without the systems backing up everywhere and having catastrophic failure.
Right. And are these pipelines running as independent services, or is there different architectures to how they run?
Yeah, so almost all of our models or system run as individual services, independent. So we use Kubernetes and containers to scale these things. We use Kafka as our pipelining solution for passing messages between all these systems. We've also leveraged Robinhood, had released something called Faust to help orchestrate the different machine learning models down the pipeline, and we've leveraged that system as well.
Yeah, that's a great point. In terms of the team setup, I know for sure, does the team sort of leverage like language experts in some sense or how do you leverage language experts? And even in the operations side of things, is there a separate operations team? And then you have like your research or ML engineers doing like building these pipelines and stuff? Or how's your team set up generally?
Yeah, so in terms of the ML side of our house, there's really three components to our machine learning team. So we have a applied research team that generally does the model building, the research side of it. What models do we need? What types of model? How do we train and test them? They generally build the models, are constantly measuring our precision recall and making changes to try to improve the accuracy over time. We have a data annotation team. So that team is labeling some sets of our data on a continuous basis. And then we have a machine learning pipeline team, which is basically doing kind of the core, like hard software development engineering work to actually host all these models, figure out how the data looks on the input and the output side, how it wants to be exchanged between the different models across the stack. And just the stack itself, all those pieces we talked about, Kafka, Faust, MongoDB databases, how do we get all that stuff interacting together?
Nice. Thanks for sharing that. So I think one major challenge we sort of associate with deploying large language models, transformer-based models, and so forth is in terms of the compute power whenever you get into production, right? And this is like the challenge we'll call with ChatGPT, for example, and like Sam Altman would always tweet and so. But I'm just curious, how do you sort of navigate that challenge of the compute power in production? How much compute power your large models sort of expend in production, and how would you cop that?
Yeah. So we do have compute challenges. Speech recognition in general is pretty compute heavy. Speaker segmentation, anything that's generally dealing with more of the raw audio side of the house tends to be compute heavy. And so those systems are usually require GPUs to do that. So, first and foremost, I'll say that we have some parts of our stack, especially the audio componentry, that tend to require heavy GPU machines to actually operate. Some of the pure language side of the house, the natural language processing models, some of them actually can be handled purely on CPU processing. Not all of them, but some of them. So for us, one of the things is really understanding the different models in our stack and which ones have to wind up on different machines and making sure that we procure those different sets of machines. So, we leverage Kubernetes, we work with Amazon and AWS. And so we make sure that our machine learning pipeline actually has different sets of machines to operate on, depending on the types of those models. So we have our heavy GPU machines, and then we have our more kind of traditional CPU-oriented machines that we can run things on. In terms of just dealing with the cost of all of that and handling it, we tend to try to do two things. One, we both independently scale our pods within Kubernetes, but we also scale the underlying EC2 hosts as well. There's actually a lot of complexity in doing that and doing that well. Because again, just talking to some of the earlier things we mentioned in our system around pipeline data and winding up with backups and crashing, and you can have catastrophic failure, you actually can't afford to underscale your machines. You need to make sure that you're really effective at spinning up machines and spinning down machines, and doing that hopefully right before the traffic comes in. So you really need to understand your traffic flows, and you need to make sure that you set up the right metrics, whether you're doing it off CPU load or just general requests, so you're spinning up your machines like at the right time so that you're sufficiently ahead of that inbound traffic. But it is absolutely critical for most people in our space that you do some type of auto scaling. At various points in my career doing speech recognition, we've had to run hundreds and hundreds and hundreds of servers to operate at scale. And that can be very, very expensive. Running those servers at 3 o'clock in the morning, if your traffic is generally domestic US traffic, is just flushing money down the toilet. So, if you can bring your machine loads down during that period of night, then you can really save yourself a ton of money.
Great. So I think we'll just jump right into some questions from the community straight away. Right. So coming in out to the first question, and this person asks, quality data is a key requirement for building and deploying conversational AI and general NLP products, right? How would you ensure that your data is high quality pre-training and post-deployments throughout the life cycle of the product, pretty much?
Yeah, that's a great question. And data quality is critical. So first and foremost, I'd say we actually strive to collect our own data. We've found in general that a lot of the public data sets that are out there are actually insufficient for what we need. This is particularly a really, really big problem in the conversational speech space. There's a lot of reasons for that. One, just again, coming back to the size of the data. I once did a little bit of an estimate, like what the rough size of conversational speech was. And I came up with some number like 1.25 quintillion utterances would be what you'd need to roughly cover the entire size of conversational speech. And that's because speech suffers from, besides a large number of words, they really can be infinitely strung together. They can be infinitely strung together because, as you guys will probably find when you edit this podcast when we're done, a lot of us speak actually incoherently. It's okay. We're capable of understanding each other in spite of that. But there's not a lot of actual grammatical structure to spoken speech. We try, but it actually generally does not follow grammatical rules like we do for written speech. So the written speech domain is, this big. The conversational speech domain is really infinite. People stutter, they repeat words. So if you're operating on just trigrams, for example, you have to actually accept I, the word I 3 times in a row stuttered as a viable utterance, because that happens all the time. Now expand that out to the world of all words and all combinations, and you're literally in an infinite data set. So you have this scale problem where there really isn't sufficient data out there in the first place. But you have some other problems just around privacy, legality. There's all sorts of issues why there aren't large conversational data sets out there. Very few companies are willing to take like all their meeting recordings and put them online for the world to listen to. That's just not something that happens out there. So there's really a limit in the amount of data. If you look for conversational data sets that are out there, like actual live audio recordings, some of them were manufactured. Some of them were like conference data, doesn't really relate to the real world. You can sometimes find government meetings, but again, those don't really relate to the world that you're dealing with. So in general, you wind up having to not leverage data that's out there on the internet. You need to collect your own. And so, the next question is like, once you have your own, how do you make sure that the quality of that data is actually sufficient? And that's a really hard problem. You need a good data annotation team to start with, and very, very good tooling. We've made use of Label Studio, is an open source. I think there's a paid version as well, labeling tool. We make very good use of that tool to quickly label lots and lots of data. You need to give your data annotators very, very good tools. I think people like underappreciate how important the tooling for data labeling actually is. We also try to apply some metrics on top of our data so that we can analyze the quality of the data set over time. So we constantly run what we call our mismatch file. So we take what our annotators have labeled and then run it through our model. And we look where we get differences. And then we do some hand evaluation to go see, well, was the data incorrectly labeled? And we constantly do that over time. So we're constantly checking new data labeling against what our model predictions are over time so that we are sure that our data set is remaining high quality.
Yeah, and I think we forgot to ask that the earlier part of the episode. It's curious, what domains does your team work on? Is it business domain or just general domain?
Yeah, I mean, it's generally the business domain. We're generally in corporate meetings. That domain still is fairly large in the sense of we're not particularly focused on any one business. There's a lot of different businesses in the world, but it's mostly businesses. It's not consumer to consumer. It's not me calling my mother. It's employees in a business talking to each other.
Yeah, and I'm curious, this next question, by the way, is from someone from the community, and person ask, what's your testing strategy for conversational AI and generally NLU products?
Yeah, so we have found testing in natural language really difficult. In terms of model building, we do obviously have a train and test data set. We follow the traditional rules of machine learning model building to ensure that we have a good test set that's evaluating the data. We have at times tried to allocate kind of golden data sets, golden meetings for our note-taking pipeline that we can at least check to kind of get a gut check. Hey, this new system doing the right thing across the board. But because the system's so big, often we found that those tests are really nothing other than a gut check. They're not really viable for a true evaluation at scale. So we generally test live. It's really the only way that we found that you can sufficiently do this in an unbounded domain. We do that in two different ways, depending on where we are in development. Sometimes we deploy models and run against live data without actually using the results for the customers. So we've structured all of our systems because we have this well-built daisy chain machine learning system where we can inject ML steps anywhere in the pipeline and run parallel steps. That allows us to sometimes say, hey, we're going to run a model in silent mode. We have a new model to predict action items. We're going to run it. We're going to write out the results, but that's not what the rest of the pipeline is going to operate on. The rest of the pipeline is going to operate on the old model. But at least now we can do an A/B test and look at what both models produced and see if it looks like we're getting better results or worse results. But even after that, very often we'll push a new model out into the wild on only a percentage of traffic and then evaluate some top-line heuristics or metrics to see if we're getting better results. So a really good example in our world would be that our customers will share the meeting summaries that we send them. And so it's very easy for us, for example, to change an algorithm in the pipeline and then go see, hey, are our customers sharing our meeting notes more often? Because that sharing of the meeting notes tends to be a pretty good proxy for the quality of what we deliver to the customer. And so there's a good heuristic that we can just track to say, hey, did we get better or worse with that? And that's generally how we test. A lot of live in the wild testing, again, mostly just due to the nature of the domain. If you're dealing in a nearly infinite domain, there's really no test set that's probably going to ultimately quantify whether or not you got better or not.
And where's your fine line between monitoring and production versus actual testing?
Can you explain what you mean by that a little more?
Monitoring and production. So you're sort of like seeing how the system performs versus actually testing out the product as it works in prod.
Yeah, so I mean, we're always monitoring all parts of our stack. We're constantly looking for simple heuristics on the outputs of our models that might tell us if something's gone astray. There are metrics like perplexity is something that we use in language to kind of detect whether or not we're producing gibberish. We can do simple things like just count the number of action items that we predict in a meeting that we constantly track that kind of just tell us, are we going off the rails or something like that, along with all sorts of monitoring that we have around just general health of the system. Are all the Docker containers running? Are we eating up too much CPU or too much memory? So that's one side of the stack. which I think is a little bit different from the kind of model building side of the house, where we're constantly building and then running our training data. We produce and send our results as part of a daily build for our models. So we're constantly seeing our precision recall metrics as we're labeling data off the wire and ingesting new data. And so we can constantly test the model builds themselves to see if our precision recall metrics are perhaps going off the rails in one direction or another.
That's interesting. All right, so let's jump right into the next question. This person asked, can you recommend open source tools for conversational AI I can build on to kickstart my journey?
Yeah, for sure. Speech recognition space, there's speech recognition systems like Caldy. I'd highly recommend to everyone. It's been one of the backbones of speech recognition for a while. There are definitely newer systems, but you can do amazing things with Caldy for getting up and running with speech recognition systems. Clearly, systems like GPT-3, I would strongly recommend to people. It's a great tool. I think it needs to be adapted. You're going to get better results if you fine tune it, but they've done a great job of providing APIs and making it easy to update those as you need. We make a lot of use of systems like Spacey for entity detection. If you're trying to get up and running in natural language processing in any way, I strongly recommend you get to know Spacey really well. It's a great system. It works amazing out of the box. There's all sorts of models. It gets consistently better throughout the years. And I mentioned this earlier, just for data labeling, we use Label Studio, open source tool for data labeling that supports labeling of all different types of content, audio, text, video. They're really easy to get going out of the box and just start labeling data quickly. I highly recommend it to people who are trying to get started.
All right, thanks for sharing that. Quickly jumping into the next question. And this person says, I know this is a very broad question, but I'll ask it anyways and give more context. How do you build conversational AI products for large-scale enterprises? What considerations would you put in place when starting the project?
Yeah, I would say so that with large-scale organizations where you're dealing with very, very high traffic loads, I think for me, the biggest problem is really cost and scale. You're going to wind up needing a lot of server capacity to handle that type of scale in a large organization. And so my recommendation is you really need to think through that, the true operations side of that stack, whether or not you're using Kubernetes or not, whether or not you're using Amazon. You need to think about those auto-scaling components. What are the metrics that are going to trigger your auto-scaling? How do you get that to work? Because actually scaling pods in Kubernetes on top of auto-scaling EC2 hosts underneath the covers is actually non-trivial to get to work quickly. We talked before also about the complexity around some types of models generally tend to need GPU for compute, others don't. So how do you distribute your systems onto the right type of nodes and scale them independently? And I think it also winds up being consideration of how you allocate those machines. What machines do you buy depending on the traffic? Which machines do you reserve? Do you buy spot instances to reduce cost? These are all, for me, I think, the considerations in a large-scale enterprise that you really need to consider when getting these things up and running if you want to be successful at scale.
Awesome. Thanks for sharing that. So let's jump right into the next one. How do you deal with deployment and general production challenges with on-device conversational AI products? For instance, in their case, after deploying the models to their users will typically experience like slow responses, high latency, high bandwidth consumption. They've tried modern compression approaches like pruning and quantization, but that has not proved anything so far or led to significant results. So how would you typically do it for deploy on-device to on-device, edge devices sort of?
When we say on-device, are we talking about onto servers or onto more like constrained devices?
Oh, yeah. Constrained devices, so edge devices and devices that don't have like that compute power to.
Yeah, I mean, in general, I haven't dealt with deploying models into small compute devices in some years. I can just share historically for things like the Kinect camera when I worked on that. For example, we distributed some load between the device and the cloud. So for fast response, low latency things, we would run very small scale components of the system there, but then shovel the more complex components off to the cloud. I don't know how much this relates to answer the question that this user was asking, but this is something that I have dealt with in the past where, hey, basically you run a very lightweight, small speech recognition system on the device to maybe detect a wake word or just get the initial system up and running. But then once it's going, you funnel all large-scale requests off to a cloud instance because you just generally can't handle the compute of some of these systems on a small constrained device.
Awesome. So I think if the person is not satisfied, they can always connect with you online and maybe discuss more. And I think it would be a crime for us to end this episode without discussing ChatGPT. And I'm just curious, this is a community question, by the way. What's your opinion on ChatGPT and how people are using it today?
Yeah, oh my God, you should ask me that at the start because I probably could talk for an hour now about that. ChatGPT and GPT in general are amazing. We've already talked a lot about this, but because it's been trained on so much language, it can do really amazing things and write beautiful text with very little input. But there are definitely some caveats with using those systems. One is, as we mentioned, it is still a fixed trained set. It's not dynamically updated. So one thing to think about is it can actually maintain some state within a session. So if you invent a new word while having a dialogue with it, it will generally be able to re-leverage that word later in the conversation. But if you end your session and come back to it, it has no knowledge of that ever again. Some other things to be constrained about, again, because it's fixed, it really only knows about things from, I think, 2021 and before. And actually, the original GPT-3, I think, was from 2018 and before. So it's unaware of modern events. But I think maybe the biggest thing that we've determined from using it, it's a large language model. It functionally is predicting the next word. It's not intelligent. It's not smart in any way. It's taken human encoding of data, which we've encoded as language, and then it's learned to predict the next word, which winds up being a really good proxy for intelligence, but is not intelligence itself. And so what happens because of that is ChatGPT-3 or ChatGPT will sometimes make up data because it is just predicting the next likely word. And sometimes the next likely word is not factually correct, but is probabilistically correct from predicting the next word. What's a little scary about ChatGPT or GPT-3 is that it writes so well that it can spew falsehoods in a very convincing way that if you don't pay really detailed attention to, you actually can miss. And I think that's really maybe the scariest part, because it can be actually something as subtle as a negation. If you're not really reading what it spits back, it might done something as simple as negate what should have been a positive statement. It might have turned a yes into a no, or it might have added an apostrophe T to the end of something. And if you quickly read, your eyes will just glance over it and will not notice it, but it might actually be completely factually wrong. And so in some way, we're suffering from an abundance of greatness. It's gotten so good. It's so amazing at writing that we actually now have the risk of the problem that the human evaluating it might actually miss that what it wrote is factually incorrect just because it reads super well. So I think these systems are amazing. I think they're fundamentally going to change the way a lot of machine learning and natural language processing work. And it's just change how people interact, I think, with computers in general. I think the thing we should all be mindful of is it's not a magical thing that just works out of the box. And it's dangerous to actually assume that it is. If you want to use it for yourself, I strongly suggest that you fine tune. If you're going to try to use it out of the box and generate content for people or something like that, I strongly suggest you recommend to your customers that they review and read and don't just blindly share what they're getting out of it, because there is a reasonable chance that what's in there may not be 100% correct.
Awesome. Thanks, Jason. So that's all of that for me.
Yeah, thanks for the extra bonus comments on the on what is, I guess, still like, it's convincing, but it's just fabrication for now. So let's see where it goes. But yeah, thanks, Jason, so much for coming on and sharing your expertise and your tips. It was great having you.
Yes, being Stephen, it was really great. I enjoyed the conversation a lot.
So before we let you go, how can people follow what you're doing online, maybe get in touch with you?
Yeah, so you can follow Xembly online, just www.xembly.com. You can reach out to me, just my first name, Jason, at Xembly.com. If you want to ask me any questions, I'm happy to answer. Yeah, and just check out our website, see what's happening. We try to keep people updated regularly.
Awesome. Thanks very much. And here at MLOps Live, we'll be back in 2 weeks, as always. And next time we'll have with us Silas Bempong and Abhijit Ramesh. Will be talking about doing MLOps for clinical research studies. So in the meantime, see you on socials and the MLOps community Slack. We'll see you very soon. Thanks and take care. Bye-bye.
Bye-bye, guys.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.